everybody, we are starting on our new chapter today. We're going to get started on our area chapter, and we're starting off the chapter by talking about classifying triangles. If you join me on page 2 of your notes packet here, you're going to see this classifying triangles, and every triangle is made up of 3 sides, and there are 2 different ways that we can actually classify triangles. So every triangle is going to have 2 different names. You're going to classify them by their angles and then also by their sides. An acute triangle has 3 acute angles, so all the angles are going to be less than 90 degrees here. In an obtuse triangle, you're going to have 1 obtuse angle, and you can see that one down here. The right triangle is going to have 1 right angle, which is right here. You'll also see that marked with that little box every time so that you do know it is actually a right angle. We can name the triangles by talking about their angles, but we can also go back and name them by their sides. In an equilateral triangle, kind of starts off with the word equal, spelled slightly differently, but we have 3 congruent sides. All the sides are going to be exactly the same. You'll often see these noted with the tick marks, which we talked about the other day. Tick marks signal to us that they are the same size. An isosceles triangle, I think about IC2, isosceles, IC2, there's at least 2 congruent sides, and those would be marked on the picture as well. So you'll see things like that. When we talk about a scalene triangle, all the sides are going to be different. So what you could see is you might actually see different number of tick marks on each of the sides, or the sides might actually be labeled with different measurements. On the next page, we're going to talk about a couple special properties of triangles. Some of these things we've kind of mentioned before, and one of them is going to be brand new for you. The triangle is a geometric figure that has 3 sides and 3 angles. There are several key properties of triangles that are important. The first one here is telling you that if we add up all the angles inside, we call them interior angles because they're inside the triangle, you're going to get 180 degrees. So if you take a look at the first example here, we have 50, 95, and n. So what we can do is 50 plus 95, which is going to give me 145, and then we'll take 180, which is the whole triangle, minus the 145, which is going to end up giving us 35 degrees. So n is 35 degrees here. We've seen examples of this before, so it's not really anything that's way too new for us. So we're going to see this. We'll talk about it actually again later this week too. In the next example, we have relationships between the sides and the angles in triangles. So something to know is that the shortest side is opposite the smallest angle. And then the vice versa also happens. The longest side is opposite the largest angle. So what I'm going to do here is pop out the webcam. I'm going to ask to go full screen here with this one. So when we talk about triangles, we're going to be looking at the sides versus the angles. And if you take your hand and actually pretend these are 2 sides of a triangle here. This is your angle right down here. It's your interior angle. As that angle gets bigger, the imaginary third side that connects these 2 together is actually going to get longer as well. If your angle down here gets smaller and smaller and smaller, notice how this side also gets smaller. So the third side is going to be longer or smaller based on how big that angle is. Now, when we talk about the angle opposite the side, you can see how you have to travel across the triangle to get back to your angle over here. So when we talk about angle versus the side being opposites, that's what we're talking about. So going back to this picture here for you, if we take a look at this example in example number 2, looking at this one, a triangular field has the side length shown. What is the largest angle? Largest angle would happen opposite the longest side. So what I'm going to do is actually look for, out of these 3 sides, which one has the longest measurement. It's this one because 220 is larger than the others. So I need to go across the triangle, and that takes me to angle E. So here, angle E is the largest. With that in mind, which would be the smallest? So we have angles D and F. So which would be the smallest then? Well, if you look at the two numbers left, 98 is smaller, so that goes across. Angle F would be the smallest here. Taking a look at example 3, the angle measures are shown here. Smallest side, smallest angle. Big side, big angle. It's the easiest way to remember it. Write the sides in order from shortest to longest. So to get the shortest side, we need the smallest angle. So looking at these angles, 44, 52, and 84, the 44 is smallest, which tells me R is my shortest side. If I look at the remaining two angles, I have 84 and 52. 52 is the next smallest, and that's side T. And the final side is the biggest angle, and that's side S. Now, to show that these are shortest to longest, we're actually going to put an inequality symbol between them because this is saying that R, side R, is going to be smaller than side T, and side T is going to be smaller than side S. So looking at these, we're able to say R is less than T, which is less than S. Okay? Take a look at example 3b. Write the side lengths of the triangle in order from least to greatest. So when I look at this one, I'm noticing that there's only two angles that are put into the triangle for me. So that tells me that I first have to figure out the final angle that's here. So if I look, 37 plus 101 is going to give me 138. So to get the final angle, remember triangles are 180, take away the 138, my final angle is 42 degrees. So looking at these, least side is going to be the smallest angle. Answer the question, which side is going to be the least? To get the least side, go to the smallest angle, which is 37, and travel across. So C is the least. This is going to be less than which side? You said A, you are correct, because 42 would be the next smallest. And finally, we would follow that up with B. This is called actually a compound inequality because we have two inequality symbols in the problem. The next one I am going to actually demonstrate with the video again. So I'm going to flip over to that here. And I'm going to show you some pieces of sticks that Mr. Rigner and Mr. Stallman cut for us. And we're going to use these to demonstrate the final concept about triangles, which is called the triangle inequality theorem. So inequality, remember, just means that we're talking less than or greater than, and we're talking about triangles. So we're also going to be talking about the triangle's sides. So I'm going to start kind of small here for you. And I have these sticks are actually labeled with their inches on them, so you can actually see those. We're going to start off with 3 here, and we're going to use these 3 to actually create sides of a triangle. Now, I'm going to kind of juggle a little bit, so don't laugh at me if this all falls apart. So if I were to put together the 10 and the 7, I could actually connect them up top here with the 5, and I would be able to actually make a triangle. So I'm looking at the inside pieces connecting. So you can see that those insides are actually going to create a triangle here. There we are. Okay, so taking a look at these, what the idea of the triangle inequality theorem does is it gives us a range for how big could the third side be. So 5 worked. If the two sides were 10 and 7, 5 was good. If the two sides are 10 and 7, could I turn it into a triangle with the third side? This is where I'm going to fall apart here, and then you're going to laugh. Entertainment, right? Could the third side be a 12-inch piece? It actually could. So these pieces are all going to work together. It's a little bit challenging to hold them up, but you can kind of get the idea here that those sides would all work. Okay? So if I keep 10 and 7, what about if I bring in this one, a 20-inch one? So if I do a 20-inch piece down here, no matter how wide I actually make this bottom angle right here with the 10 and 7, the 20-inch piece is always going to be longer. So I was able to make a triangle with pieces that are 5 inches and 12 inches, but not 20. So how do we go about figuring out what could actually be our range when we're talking about the triangle inequality theorem? So the way that you actually do that is you take the two pieces. And if this angle were really, 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 really teeny tiny, it would be close to, it would have to be a little bit larger than 3 inches, because the difference between these two is 3. And if I put these bottom to bottom and then close these up here, that's a 0-degree angle here. I do not have a triangle yet, but the side, this length, the side length here, the third piece, would have to be 3 inches long, okay? So if I open this up in the teeniest, tiniest little bit down here, that side length now that's up at the top is going to have to be a number just slightly larger than 3. Okay, so our first step is to go ahead and subtract the two sides. And that tells us the lowest part is going to be a 3, which means our third side is going to be larger than a 3. Now, we could take our triangle and we're imagining the third side here, okay? So you're using your imagination and connecting a line between these 2 points here. And if we kept making this angle on the bottom bigger and bigger and bigger and bigger and more obtuse and more obtuse and more obtuse and all the way up to like 179 degrees, so we almost have a straight line here, our side length is going to be just under 17 inches because aren't 10 plus 7, 17. So if I put them straight next to each other, I now have a 17-inch piece of stick right here. But if I'm going to close these up a tiny little bit to actually create that angle at the bottom, less than 180, and therefore create a triangle, that third side is going to be slightly less than 17. So the 2 steps here for triangle inequality theorem are to take your 2 sides, subtract them, take your 2 sides and add them, and your third side of your triangle is allowed to be somewhere in between. Now, we said our third side would have to be somewhere between 3 and 17. Do you see why 5 works now? 5 is in between 3 and 17. 12. This worked. It was in between 3 and 17. The one that didn't work, however, was the 20-inch piece, because that is outside that range. Okay, so a couple examples in your notes packet here are going to go through and kind of explain how to actually calculate some of these. So looking at the first example, Marina has chalk to draw on a sidewalk. 2 sides of the triangles are 15 and 22 inches. What are the shortest and longest possible for the third side? And we're going to use whole numbers. So step 1 is to do a subtraction problem. You just need to do the bigger minus the smaller. Step 2 is an addition problem. Doesn't matter which way you add. So our third side has to be between 7 and 37. But remember, it can't actually be 7, because 7 would be if the sticks were right up next to each other, not creating that triangle. So the smallest number it can be, the shortest, would have to be 8, because we're going for whole numbers here, so 8 inches. And the longest would have to be just under 37. We're going for whole numbers, so the next smallest number is 36. Now, if they didn't suggest whole numbers, we could say 36.99999, and that would actually work. In example 5, how do we check one? If we have 3 sides given to us, I recommend you just take the first 2, and you're going to subtract, and you're going to add, and your third side needs to be between 3 and 13. So now check the third side. Is 15 in between 3 and 13? 15 is not between 3 and 13. So does this form a triangle? So there is no triangle. Out of the multiple choice answers that are here, which one could be part of this triangle? Which one could be the third side? So if you picked the 10, you would have been correct, because 10 does fall between 3 and 13. So triangle inequality theorem gives us a range. If we know 2 sides, it gives us a range for what the third side could actually be.